This is part 2 of a 3-part series explaining how SimTools works and how to set it up. In this video I'm going to explain how to set up communications between SimTools and the game, set up communications between SimTools and the motor driver, set the axis limits and assign degrees of freedom to each axis. There are 2 channels of communication you need to establish between the SimTools and the game, and between SimTools and the motor driver, such as SCN, Arduino, JRK or SimAxe. So let us first look at setting up X-Plane. Most games won't need this kind of detailed setup, but this one certainly does. I've been getting into DCS recently, and all that needed was to drop the plugin over the plugin updater, and it simply worked. So let's look at X-Plane. Start X-Plane and click on Settings and then Data Output. You should now have a screen with all the checkboxes. Check the following 6 items in the last column called Network via UDP. So number 3, speeds. Number 4, Mach, vertical velocity indicator and G-load. 16, angular velocities. 17, pitch, roll and headings. 37, engine RPM. 38, propeller RPM. Check the box Send Network Data Output and enter IP address 127.0.0.1 and port 4123. Set the UDP rate to maximum, which is 99.9 packets a second. This sends 1 packet every 10 milliseconds, and then click Done. X-Plane should now happily send flight data through port 4123. It's worth noting that X-Plane is very CPU intensive, and sending data to a port is not its highest priority. So when initially setting up communications and testing that things work, turn down the graphics sliders so that your frame rate is greater than 30 frames per second. If you don't, the motion platform may not run smoothly, as packets may be missed, causing jumps between motion cues. We now turn our attention to setting up SimTools to receive the information from the game. I'm going to assume that you are wanting to interface SimTools with the Arduino Uno running the SMC3 sketch. I'll make another video later to explain how to set up the Arduino and the SMC3. Before we get started setting up the interface, you're going to need some information about what port your Arduino or motor driver is using. When you plug a USB cable from the Arduino into your PC, the Windows operating system will automatically allocate an exclusive port for it to use. If after that you don't move the USB cable into a different slot, Windows will remember the port it is assigned. The reason it needs to assign a port is it must convert the data from SimTools into a serial stream of data to be read by the Arduino. To do this, it creates a communications port. Now there's a few ways to find out what port your Arduino or other motor driver board is using, and the first one is to go to the Windows control panel and click on Device Manager. And as you can see here, my 3 Arduinos have been assigned COM ports 5, 6 and 7. Another way to find out what COM port Windows has assigned is to use the programming utility for the Arduino, which of course is a free download. If you have an Arduino, you will probably already have this software anyway. Simply plug the Arduino into the PC USB slot you intend to use, or into your USB hub, and open the Arduino programming utility, also known as the Integrated Development Environment, usually referred to simply as the IDE. Go to the Tools menu and click on Serial Port. You will see a few USB COM ports existing already. Simply unplug the Arduino cable you're going to use and which one disappears. To check if this one is correct, you should try uploading the Blink program, which you can find under the sample sketches here. Now we know the COM port or ports, click on the SimTools game engine icon and then click on Interface Settings. The icon for the game engine will most likely be in the notifications area in the lower right of the screen. Firstly, click on the drop-down box under the heading Interface Type and choose your board. For the Arduino, it will be serial. Choose the COM port your Arduino is plugged into from the drop-down box. Then set bits per second to 500,000, 8 data bits, parity to none, and 1 stop bit. This sets the parameters for the packet of data sent from SimTools to the Arduino via the USB interface. The output bit range should be 10, which provides for numbers between 0 and 1023. This is the maximum analog precision the Arduino uses when converting voltage to binary on its analog inputs. The interface output field is set to the number of actuators you have and their corresponding axis numbers. So in my case, I have 6 actuators which are controlled by 3 Arduinos. The Arduino interface settings you see here controls our actuators 1 and 2, which are referred to as A and then the angled brackets axis 1A, and then B angled brackets axis 2A. Make sure you save frequently, because if you click on another tab, your settings will be lost. These settings correspond to the axis names on the axis limiting page, which I'll show you in just a moment. This means that for interface 2, they will be A axis 3A, B axis 4A, and then A axis 5A, and B axis 6A on the third Arduino interface. You might have seen some screenshots with a third assignment on one of these lines, usually beginning with a C. And this is for driver boards that can handle 3 motors, for example, roll, pitch and traction loss. I only have 2 per Arduino because my Sabertooth 2x60 can only control 2 motors. I tried the output rate at 1 millisecond, but it didn't seem to make much difference. I've since returned it to 10 milliseconds. The reason I did this was that X-Plane can only send a maximum of 100 packets of data anyway, so there would be no point trying to send 1,000 packets of data per second to the Arduino, which it would do if it was set at 1 millisecond. The other aspect is that the Arduino runs a software loop which takes about 1 millisecond to complete, and I don't want to slow that down by interrupting it with unnecessarily having data arriving on its COM port. So let's turn our attention now to setting up the axis limits. I initially set all the axis limits at 10% for safety. You'll see the actuators move, but they won't drive past the limit switches and cause damage if something goes very wrong. Eventually you can increase this limit and watch how far the actuator moves. The goal is to get a percentage value that moves the actuator between the limits but without actually hitting them. It may be as low as 30% or it might be as high as 100%. For SCNs, I've seen some users put this value at 90%. Now click on Axis Assignments. Work with only one force or degree of freedom at a time and leave all the other values blank. Clear all the forces and direction boxes so it looks like this. Now set axis 1 to heave. Click on the Output Testing button. Move the heave slider a little from side to side and note which actuator moves. This is axis 1. Go back to the axis assignments and clear axis 1 by typing a dash or simply selecting the blank area. Click on axis 2 and do the same as you did for axis 1. After completing this for each of your axes, you will know which axis corresponds to which actuator, and this is what mine looks like. We can now set up combinations of actuators to coordinate a movement like pitch or roll. For my flight sim, I started with pitch. I found that I could have higher settings than shown here, but the problem comes when you combine forces such as pitch forward, roll left, and negative heave. When combined, the front actuators are very close to hitting the limit switches. Now you might say, well, move the limit switches further apart. Well, you can, but the risk you run the risk of damaging the actuator when it drives past the limit switch due to inertia or gravity when something goes wrong. You'll just have to try this yourself to see what I mean. While I've been experimenting with the settings, these limit switches had quite a workout and certainly have prevented damage to the actuators. Watch what happens when I combine roll, pitch and heave. I found that when you test your settings with output testing, it uses the default profile. I might be wrong there, but what I do is I set up my X-plane assignments to how I think they should be, save it, go to the default profile, click reset, then go back to X-plane profile and hit save again. SimTools will then ask if you want to save the settings to default and then click yes. Now, when you do the output testing, it will be using the same setup as your game profile. You can use the default setting as the basis for other game profiles. For X-plane, some data comes in on extra 1, extra 2 and extra 3. SimTools uses these names for forces that already exist, like roll, pitch and yaw. They're just general labels for situations when the game patch software needs to send modified motion data as well as unmodified roll and pitch. So for a 6 actuator platform, roll is achieved by not moving the back 2 actuators, they become the pivot points, and for a left roll, moving the 2 left actuators down and the 2 right actuators up. To get the actuators to move in the proper direction, you use the direction checkboxes to reverse the actuator if you need to. You can change the direction by checking the box to the left of the force, and it turns orange when checked. Here you can see axis 2, 3, 5 and 6 providing the roll. Pitch data needs the use of all the axes. Some are already moving in opposite directions, so no reversing is necessary. Yaw needs to have some actuators retracting while others are extending, and heave is perhaps the easiest of all, with all the actuators moving in the same direction. Now in theory, the percentages for each axis allocation should add up to 100% by reading across the degrees of freedom columns. And what this means is that if you combine all the forces that you want the actuator to respond to, the actuator rod should be at 100% of its travel when all these forces are at maximum. Now you can have a total of more than 100% if you are sure that the forces won't combine to be more than 100%. If it does exceed 100%, then a condition known as clipping will occur, and you can get some very weird and sometimes very violent movements. So I'd recommend starting with forces that add up to 100%, test, then make small adjustments and then test again. You'll be able to both feel and hear when the clipping occurs. The FLT area are a set of filters that you can use for your simulator to smooth out the motion. It helps to get that feeling when you come out of a roll and the aircraft settles back into level flight. Play with the filters once all the axis settings are set and you've played the game for a while. I tried using 25% on roll and pitch and leaving the other forces without any filtering at all, but I've recently removed all the filters, and I might return to the filters sometime later but be scientific and change one thing at a time. Try it out and see how it goes. Once you've allocated your forces, you'll need to use output testing to make sure that the actuators can move in every maximum position and not hit the limit switches. For example, maximum forward pitch and roll with negative heave. Move each slider to make sure no actuator hits the limit switch. Try combinations of forces, and the goal is to get the maximum travel from the actuators without hitting the limit switches. If you've selected Game Manager and Game Engine to start with Windows, then they can be found in the notification area at the bottom right of the screen. Simply click on them to open them. If you click the Close checkbox at the top right corner of the Game Manager and Engine windows, it simply minimises the window back to the notification area. It doesn't actually exit the software. The Game Manager monitors which games are running and loads the associated profile if it exists. So when starting out with your tests, it's worth keeping the main level at a very low percentage until you are confident you're not going to damage anything. If you set it at 0%, the platform will still move, but will be very gentle and limited in its movement. Once you set it, it will remember the level and will start with that value when it boots up. Once things are working, you can start playing with the tuning center, which is more like a music graphic equalizer, where you can change the magnitude of the levels of motion coming from the simulator and how they are sent to the platform. It's worth spending some time with the tuning center, as it can really change the behavior of your platform from simply moving about to one that really makes you feel like you are there. Now, I'll cover the tuning in the next video, and as I've already covered the axis assignments, all that remains for the final part is tuning and using the game manager and creating profiles. Well, I hope that's been useful. Bye for now.